Let's take a look at number 10. Again, there is no simplified version. It would be exactly the same as the function that we have here. There was no factoring or canceling necessary. That also means that we didn't find any holes or discontinuities in our graph. Vertical asymptote at x equals -2. Let's just set the denominator equal to 0 and solve. Horizontal asymptote is determined by the relative powers of the denominator and the numerator. Notice that the powers in these two are the same. When the powers are the same, the horizontal asymptote is given by y equals a over c, which are the coefficients of the numerator and the denominator. So coefficient of numerator over the coefficient of the denominator. In this case, y equals -6 over 1, or -6. We'll draw that in as a horizontal dashed line. Moving on to the x-intercept. Remember, the x-intercept occurs where y equals 0. And in a fraction like this, the only way that y could be equal to 0 is if the numerator of our fraction could be equal to 0. So set that numerator equal to 0 and solve for x. In this case, x equals 0. Now if our x-intercept is 0, then guess what? Our y-intercept also has to be equal to 0. Just to make sure, plug in 0 for x, and you get the numerator becomes 0, denominator is 2, so the y-intercept is also equal to 0. Now, that means we only have one actual point on our graph, so we're going to have to find a couple more. We really like to have at least 2 on each side of the asymptote in order to be able to sketch in our graph. I'm going to choose the values -4, -3, and -1. That's on both sides of the vertical asymptote. If I plug in -4 for x, I get -12 for y. If I plug in -3 for x, I get -18 for y. And if I plug in -1, I get +6. Let's plot those points. -4, -12. That's 5, 10, 11, 12. At -3, we're even lower than that, at about -18. And at -1, we're at 6. Notice that this is kind of a tall, skinny graph. Let's connect those points, remembering to approach our asymptotes. And remember, this is just a sketch. We do expect our sketch, however, to be a smooth curve, not to cross the asymptotes, not to have any right angles, not to look like a horseshoe, and it should be a nice reflection across the intersection of those two asymptotes. I think we did a pretty good job. Let's write our domain and range, and we'll be done. For our domain, remember we're going to go all the way left to all the way right. Notice that we have points at all real numbers except for one, and that's -2, where the vertical asymptote occurs. So -infinity to -2, open at -2, union, the other branch of the graph starts at -2 and goes to +infinity. We'll write the range for the two branches the same way. The first branch is negative infinity all the way up to -6, but it doesn't touch -6. Then we start on the other side, -6 to positive infinity.